Alright, this is the first video. Today is August the 27th. This is the first video for PPI. Here we have an ISO board configured just like the engineering demo board that we sent last week. And we have inside this cabinet there is a 6-pulse rectifier, not a 12-pulse rectifier, that is being powered from a 243 phase source. We have a load lamp on the bottom, on the top, and here we have our board that it's inhibited. That's why we have the power LED and the self-start LED on. Notice that on the center multimeter we have the AC input measuring 245 volts AC, and the corresponding DC output is 0. I'm going to ask Tony to soft enable the board, and we'll notice that the output will start increasing to a previously set value of 175 volts that was chosen randomly. 175 volts DC. At that point we notice that the voltage is voltage limited because we have used the voltage limit potentiometer to adjust that to 170, and the red soft start LED is off. Now what we have here is and we're going to do this again. This is the time that we soft enable. This is 1 second per division. We're looking at the soft enable. Here we see the, although this doesn't represent much at 1 second per division, this is the delay angle at TP3, but we see certain changes in duty cycle. And yes, we see what it's being reported by PPI when the board is at zero output. When we soft start it, it tends to overshoot. It undershoots, and then it's trying to regulate. We're going to take this shot again. So again, we're going to look at the soft enable, changes in the duty cycle, and we'll see the output. Notice that, go ahead Tony, set it up. We have two markers. The first marker, it's at the 175 mark. That's the setting that we have it at, 100 per division, 175. And this right here, the dashed marker, is for the maximum output that we're going to do at the very last. So we have it ready. It's an initial shot. Go ahead, Tony. Enable. So the unit has been softly enabled. 1 second per division. The data is being collected before it's displayed. And there it is. So go ahead and stop it. So we got changes in the duty cycle. We have the board enabled. And then here we have the output going all the way to the maximum. That's the dash. It overshoot, it undershoot, and then it started to regulate. So again, let's take a look at this marker with respect to, now let's change it from single to an auto, Tony, please. Okay, and let's keep an eye. Yep, let's go ahead and change it to 200 milliseconds so that we don't have to wait. And we go for oh, actually it's just auto, right?
Yeah.
Okay. So we'll show it, and there it is. So we can see that this is the full bandwidth for the output. So we decided to keep it at the 175. So this will be the 175 average. That's why we wanted to point out that on the soft start it went all the way up, and it started, and it'll eventually get there. This because this is already steady state. The last thing I'm going to ask Tony to do is to change the voltage command and increase it to increase the voltage limit to bring it to back from 175 as shown on the meter, bring it back to the maximum of 317, 318 volts. And now we look at the output. Here we see a uniform delay angle, and we see that just capping here we have that second marker. So I think this is the end of the video where we have shown that yes, we have the same overshoot, and we're gonna change that in a second video, try to remedy that and try to make sure that it behaves as desired, that it's going from 0 to the desired setting without actually overshooting to the maximum.